Okay. Good. Do you hear me? It's working?
Okay.
It's working? It's working fine? Okay. Good. Yeah. Then it's my greatest pleasure to announce the latest keynote workshop that we're doing up here. We'll have the presentation of the PTCC at 4. But the last session we have here, last technical session, is a workshop on security of connected vehicles from Gael Musquet. And as you see already, Gael brought a lot of interesting looking material. So I'm sure that it will be a very cool highlight of this year's PhD school with a lot of action. And so I will briefly introduce Gael. So Gael Musquet is a French hacker and meteorologist, particularly involved in the anticipation, forecasting and prevention of natural disasters. In 2011, he was one of the founders of the OpenStreetMap France Association, which he chaired from 2011 to 2014. His activities led him to support SOS Méditerranée on technological and data collection aspects. He is a founding member of L'Hermitage in Utrecht and of Hackers Against Natural Disasters, and which he subsequently chaired. He is an advocate of empowering people through new technologies to better anticipate risks, and his expertise in risk prevention is sought by the Army and in preparation for the Paris Olympics. So this is what you can find on his Wikipedia entry, and I'm more than happy to give the stage to you, Gael.
Thank you very much. So this afternoon I will talking about cybersecurity in the automotive field. So I'm the captain of a ship called the Red Pearl, like Jack Sparrow in the Pirate of Caribbean. I was born in Guadeloupe, so my car can be uplift to the 3rd floor. So I just come here with some pieces of cars. So in order to introduce how you can starting to hack cars and what are the challenges of the automotive field. So first of all, we want to talk about the 5 ways you can hack a car. There is the physical way. So the hackers or thieves are using the mechanical way to open the cars, because in cybersecurity, if you have physical access to the IT systems, it's done. You can consider that the system is compromised, so you can't use it anymore. So the first goal is to access to the interior of the car. So I have this key and this barrel, and my demonstration is to show you the state of the art of tools that thieves or forensics or some people are using to open cars. So this is a lychee. This is a tools dedicated to open doors of cars. So the challenge is that when you are logging on your webmail, for example, you just set up your login and password. It is the same thing in the car. So you have the key, kind of your login, and you put this key in this barrel, and you just have to turn the key. If this is the key, it's open the car. If you don't have it, you have this kind of tools that you can put in the barrel. So it is the same mechanical form that you can put in the barrel, and you have this kind of tools that help you to determine where are the in French we say paillettes. I forgot the word in English, but you have, yes, you are the pins. Thank you very much. Where are the pins x-axis but also in the y-axis. So sorry for the people who are just looking online, but I will give these tools to the people physically there in order to show them and to help you understand how we start to hack a car. The first way is mechanical, so you can use or try to find with these little tools where are the pin exactly on the x-axis and y-axis. The second way, you have to access to the electronic parts. So there is a diagnostic socket in your car, just less than 1 meter from the wheel, and this diagnostic port or BD port is used in order to understand how much gas the car is consumed, but also for the car maintainers to determine what are the problems and update sometimes all the computers in the car. We can use this kind of ports in order to reprogram a new key. So for this time, it will not be a mechanical key, it will be, sorry, I'm looking for my key fob. It will be a radio key like this. So as you can see, I have two buttons on this key. One button in order to open the car and the other one to close the car. But this key is always trimming a little radio frame in order to allowing me to open the car without touching any buttons. It is a without contact key fob. So this key is transmitting data on two frequencies, and the first one is 433 megahertz. So when I push this button, this key fob is transmitting a frame with a rolling code that have a key to encode the data received by the car that said her to open the door or close the door. And the second frequency is 135 kilohertz. That is used in order to determine if the car is inside or outside the car, in order to not close the doors with the key fob inside. The other functionality of this key fob on this frequency is to allowing the car to start when you push the button start on the car. So it's kind of immobilizer. If the key fob is not in the car is not starting. And the third functionality is to be allowed to open it without touching any buttons. So we have three kinds of attack on this kind of keys. The first one is kind of electronic warfare. So we are scrambling, emitting a strong radio signal on the same frequency, so the car is not listening to the key fob. So you can push the button, but the car will not open or close. The second kinds of attack is replay attack. So when you have scrubbed the signal, the car is not receive the signal, but you can saving it with this software defined radio. So you transmit a signal in order to scrub the signal, and you just waiting for the people just push the button and receive this signal, and your goal is to forbid the car to listen to his key fob, but you saving the real signal with the rolling code. And afterwards, when your victim is out of his office or car or parking or house, sorry, when your victim is out of his office, his house or parking, You just replay this signal. The car don't heard before, so the car is considered that this signal is a good signal, and so it's open or close the door. This is a replay attack. You have finally the third kinds of attack. It is a relay attack. So you need two kinds of radio like this. One with my with a friend that's following the victim in a queue, and for example, or just scanning the house or the office with a high gain antenna. The goal is to receive the signal streamed by the key fob every time. Just relay this signal to the car with my radio, and to relay this signal just in front of the door of the car, so the car is considered that the key fob is just next to her, and at this time the car is open. You have some security like ACK, so acknowledgement that the key is really the real key and just not a relay of the signal of the key. But even with this kind of security, if you have two software defined radio like this, you can have a two-link radio link, a two-way radio link between the car and the key fob. So the goal is to just, for the attackers, to have a virtual link, a radio link through Wi-Fi, 4G, Bluetooth, and so on, to relay the two signals from the key and from the car, and to synchronize them, the acknowledgement, and to allowing, first of all, open the car, and second of all, to start the car. Because if you are relaying this 155 kilohertz signal, you also relay the immobilizer signal, so the car is starting. I just have on the table this reel, as I can just put the car on the third floor. I just want to show you another kind of attack we have on radio on the car is TPMS sensor in the wheel. So the TPMS is mandatory sensors now since 2012 in Europe. All car manufacturers must put a sensor in the wheel in order to understand or to signal that the wheel is overheating or under pressure. This kind of device are not securely transmitting the radio data. There is no signature, no authentication, and no cryptographic means to transmit the pressure, the temperature, and the voltage of the sensors to the onboard of the computer on board of the car. So this kind of device, in order to is used by car manufacturer to exciting the sensor. So what you will see here, will give you this device, is a way to exciting the sensor. So is waken up, transmits the pressure, the temperature, and the voltage of the sensor. And with this device, we also receive the ID, because you have a unique ID of the sensors to be sure that you receive the pressure of your tire, not the tire of the car in front of you or your neighbor, but your car, and of course the front left tire, the front right tire, and so on. So this is the schema you have here that represent the car and the four wheels. So now here I have only one, but you can see on the screen the ID on 32 bits. You can see the pressure, the frequency of the sensor, and the level, the voltage level or level of the battery. So what I am showing to you on this screen is RTL underscore 43, who is a free software, free open source software that can decode with software defined radio like this. So the car is not here, but I have the frame. So you can use this TV receiver, USB TV receiver, in order to just decode all the data sent by this sensor. And with this software defined one, you can re-encode the data because it is not encrypted. So you can, on the air, just send the to the car a fake pressure or a false temperature. The goal is to have a kind of social engineering in order to push the driver. So if it is the car of normal people, it's not. It's okay. But if it is a person of interest, so an ambassador, a deputy, a lawyer, and so on, this kind of people of interest have very sensitive cars. So the doctrine today is stop as soon as possible when you have defect or this kind of problem on a convoy of this kind of people. So they are not driving on the motorway at slow speed, so the stress at 130 kilometers per hour and the stress at 50 kilometers per hour and when the car is stopped is not the same. So the social engineering is to inject near to the car false frame that give 0 psi, so the tire are flat, and the temperature you can put it at 300 degrees if you want, because it's non-encrypted data. So you have two kinds of retreat. This is the fourth way you can, with this kind of social engineering attack, disturbing a driver of people of interest. The other kind of cybersecurity kind of attacks you can have. So the first one is physical. I show you with the key. The second one is a radio attack. The third one is on electrical or electronical attack on the bus of the car. The fourth one is software and data attack. So what I have in my hand is a Raspberry Pi 4 with a battery. This is just a battery, and this is a small HDMI 7 inches screen that can virtualize the dashboard of a car. So on this Raspberry Pi, I installed automotive grade Linux, who is for me one of the best open source software in the automotive field. So the guys and the firms who are contributing to the Linux Foundation, it is a dedicated project of the Linux Foundation. They just bring 70% of what a car needs for the infotainment inside of the car. So you have your radio, you have a portable child that dealing with your phone, you have a media player, a messaging manager, all the navigation software needed, a camera in order to see what happens in the back of the car when you are just driving back, and it is like it's a little bit tricky to give you the batteries and so on and the dash, but it will be on the table if you have questions, or if you want to test it afterwards, you can do it. So what you have here is like an iPhone or Android store. You have some kind of apps, and what you have to understand is today cars are just big cell phone with batteries, motors, electrical motors, or gas motors, gasoline motors, and each icon you have here today on a car is a web page. So it is all this a screen is on HTML5 web page, and when I click on it, you can interact with the car uh, as if you was in a real car. So you can set up the temperature of the air cooled system. You can set up the heating of the chair. You can go back dealing with your radio if you want to listen to music or your favorite radio station. Can go back, can show you the air cooled system. All these software are now have a very high quality. This software is so good that Toyota, who is the first car manufacturer, decide to use this open source software for all his cars today since 3 years now. The first one was the Camry, the Toyota Camry, who is a big Berlin of Toyota. So they start to deploy automotive grade Linux on their car. So what is the the problems we can have? The problem we have already on these cars is that the fact that the software is now updating by over the air. Sometimes they are not updated, so when you have a software problem now on the car, it is the same problem that when you have a mechanical problem. So you have to recall all the cars, and it can really cost a lot of money to the manufacturer. I think now we have a Kia action of class action in the US because people who buy Kia cars uh, believe that Kia don't give them all the tools or the advice in order to update their car, and there is a lot of Kia in the US, also in Europe, that are who are fifth. There is more than also 140,000 cars stealed in France each year. So each 4 minutes there is a car who is stealed in France, and this is a combination of all the five cybersecurity problems we can have. First one, I repeat, mechanical. Second one, radio. Third one, electronic. Fourth one, the software. And the fifth one is data. So this kind of data who is going without encryption through the air over the radio is a threat for the security of the cars. The last things I want to show you is the relation this car have with their connected device. So when you start your car, you always, at this time with new cars, connect your phone by the cable USB. It is the more secured way to connect to your car. But you also connect to your car through Wi-Fi and Bluetooth nowadays. So what I did is to build a little daemon that is looking for the relationship between my phone and my watch. So I just want to listen, because the data in Bluetooth between my watch, my cell phone and my car are not strongly encrypted. They are encrypted, but they are not strongly encrypted. So the goal is to intercept all the frames going from my watch to my phone, or from my phone to my car. So I have this small daemon who is running uh, on my laptop. So this is the demo effect. I hope it will be okay. So what I'm starting to do is to launch the packet sniffing with Wireshark. And what I'm going to do is to force my watch to talk to my phone. So the car is on, my phone also. So my phone is connected to the car, and my watch is connected to my um, cell phone. My cell phone is just used in this scenario to force the watch to update to my phone and to the car. So I can receive SMS and also set up a push button in order to say that I want to receive a call or to deny to a phone, a phone call. So the first part is okay, so we are listening, and I'm going to force this one be 1, it's okay, 0. So it's a small app that you I think always seen. So it is a Fitbit. Is it a Fitbit Versa 3 or 4? Oh, don't remember. It's a Fitbit Versa 3 watch, and you have my BPM, the BPM of my hertz. So my watch is already streaming my BPM of my hertz to the cell phone. So this data is real time, and I will just swipe here in order to force the watch to start synchronized between my phone and the car. And please, it's okay. Yes. No. So, I start it again. Okay, so I swipe again up, uh, uh, and I think we are okay. Up, so just to stop it. Up. So what you are seeing here is the connection session between the watch and my cell phone and my car. And what I am looking is for on SMS I received from my bank. Is a real SMS received yesterday. So this message is from 38985 for people who are client of La Société Générale. I think you recognize this number, and this is a security code used for authorized connections. So it is a two-factor authentication. So what you have to imagine is the fact that an attacker or a pirate who is near you can intercept the data who is going for your watch, from your watch or from your car to your cell phone, and to just have the real code. So this one is DDNC5N, and for example, if the guy or the attacker just reset your password on your webmail, or I don't know, your bank account, it can receive the second factor authentication that your bank or your webmail sending back to you. And I think I have a second SMS, so you don't. The second one is also from yesterday, so you have You have the code here. So I just put a filter in order to be sure that I receive the message from this kind of sender. So I always put a filter because I'm just looking for the SMS that I really need. But it is also a way through the radio between your car, between your watch and your cell phone, to compromise your car. I will stop there. I will just prepare, if you have question, another demo with the replay attack to show you how we can use this kind of device to saving the frame. Uh, do you have questions? Little bit afraid. Hope not. Yes. It is for developers, so you just have to download like the Raspberry Pi OS on image. So you just write it on a SD card. But you can also virtualize the image and put it in VirtualBox or QEMU and so on. But you already have 70% of what you need. These 30% more are just customization. You put the good color, the good logo of your brand. 70% of the core of what you need in infotainment is already setting up here. So you just have to, you can connect. My dream when I was younger, 10 years ago, was to just SSH my car. You can now SSH your car. You can shut down a daemon like your car today is just a server you interact with. So the UI is of course the touchpad. You can just plug in a keyboard or a mouse, but you can also, you have on this, oh, I can show you, I think it is here, you have a terminal, an official terminal. So you can interact directly with your keyboard and your mouse. So of course for debugging, or if you have a developer or a web designer, you have an official terminal client that can be used in the to setting up of all things you need. And the most difficult part today with this kind of system is the fact that when it is too much customized, it's a little bit tricky to understand what the manufacturer did on the car. So for forensic things and so on, it can be a little bit tricky. But we have today a big community of people who are developing an open source way to drive, or to drive the infotainment part of the car. And for me, and for a lot of people today, it's the best way to develop secured cars, because you have less line of source code between two cars than between an iOS system and Android system. Android and iOS are sharing more source code together, even if they are concurrent, than two cars, because the car manufacturers are developing each time their own operating system, their own way to drive and to communicate with the sensors, the computers on board of the cars. So it's it's so complicated today to have a forensics or a good way to do that. There is a lot of, oh, no, not a lot, but there is now norms, standards to tell the manufacturers and suppliers that you must use and so on. Okay, but when you are a gangster, you don't have nothing to deal with this kind of standards and so on. You just want to steal the car. So every kind of process or tools that can help you to steal the car is okay. And these guys have time, they have money, and there are a lot of people working for them. this is not the case for us from the cybersecurity field. Other question? It's okay? Oui. You just have to. I have two Bluetooth boards, a receiver, transceiver, two on this one and two on my laptop, in order to be sure to scan all the channel of the Bluetooth used by the watch and the computer and the car or the. So I'm scanning two ways with this with the Raspberry Pi. I scanning on two ways this on the Raspberry Pi and on two ways on my laptop. And the goal of this little demon is just to reassemble all the frames that received on the 6 channels used by the Fitbit to send the message. It is just in no, it is not connected. My laptop, exactly. It is just in a Bluetooth in monitor mode. Exactly. All the traffic on a specific MAC address. But not MAC, but yes, it's a kind of MAC. I forget the name for Bluetooth, but on the ID, the hardware ID of my watch. Because I can listen also on your own watch. So I want to be sure that I listen to my watch and that I don't have a lot of frame from your watch or your Bluetooth device on you. Yeah, yeah. Otherwise, I have the watch of everybody around, but it is not so challenging because now you can filter. You have so I just filter on the TCP port because it's a local host daemon. But with 10 Raspberry Pi, for example, with dongle connected to them, you can scan, and if you have a high-end antenna, you can scan all kinds of frame, Bluetooth frame that around you, and just have to filter on the BSSID, SSID, like Wi-Fi, of the Bluetooth that you want to target. Oh, you can on all kinds of Bluetooth device. You can sniffing the data. What is a little bit tricky is to discovering the key. So the key that are that is encrypted the data between my watch and the car, or my watch to my cell phone. I already did like I forget the name for the Wi-Fi parts we used. Oh, I forget the name. So we have a software that trying to deciphering the WPA. Yes, but I forget the name of this software. But there is the same software for the Bluetooth part that help us to decode and to recovering by a lot of packets the key that you want to discovering and this key sometimes is just 5 numbers. You have just 5 numbers. The key is just 5 numbers. So if you just trying to discovering by using all the number between 0000 to 99999, you will at a time discovering how you can deciphering the data. So you have different kind of encryption in Bluetooth, but some manufacturers are not do not respect the implementation of all these encryption way, and this is why this Versa 3 is less secure than the Versa 4, who have more ways in order to encrypt the data. Yes. Air crack NG. It is like a crack, air crack NG. Yes, but the subtlety you have in Bluetooth, that's the fact that this frame are split in channel. You are like the Wi-Fi. You have 11 channel in Europe. Channel 1, 2, 3, 4, 5, 6, and in 2.4 gigahertz, and I think we have 20 channels in the 5 gigahertz uh, 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 frequency. And I'm just looking for Wi-Fi analyzer and to show you what I'm talking about. If you have a channel graph, this is the channel used by all the Wi-Fi networks here on the 2.4 gigahertz band. And in Bluetooth, this is the little subtlety that the data are spread through multiple channels, not only the channel 6. If you are in Wi-Fi channel 6, you stay on channel 6. In Bluetooth, you can spread the data on all the channels or many channels. It is also a security to be sure that you can just stay there and listen to a frequency and to be allowed to receive all the data. Other question? I don't know if I have a little bit more time. 60? Oh, 16. Okay. So what I'm going to show you is a software tools called GNU Radio, and GNU Radio is like GNU Linux. It's a distribution of software that can help us to driving software radio, software defined radio. So does someone already used who don't know what is GNU Radio? Okay, so GNU Radio, it's an open source software. It's an open source library of software, and you have in the core every small operation or compute that you need in order to driving a software defined radio. So you have to imagine that this radio is just an empty device, and with GNU Radio, what we are going to do is to send software inside of this radio and transform it in a digital television transmitter or receiver or FM band receiver, or just in my demo we will just listen to a frequency and recording all the frames received by the radio and transmit by the key fob of my car. What is really nice with GNU Radio is the fact that you can program this radio by block. So you can also write your own source code with Python or C or C++, but this block oriented IDE is really nice in order to simplify the way we are talking to a radio, or how we are dealing with the radio field. So it's really more simple to program a radio with this kind of IDE. So I'm going to connect the radio. So this radio is a Pluto, Adam Pluto. So it is a device from Analog Devices. It's a educational device, in fact, but you can receive and transmit every kind of signal from 100 megahertz to 6 gigahertz. Yes? Oh, there is one for receive, another one for transmit. So you have an emitter and a receiver and a transmitter. Or you can use the two antenna for receive. And you can alternate, and you can have multiple input, multiple output. So it is the first version, but you have a version with 4 antenna. So you can split and multiplexing radio signal. We can do almost everything with that. You can virtualize the satellite. You can just transmit in DVB-T, DVB-T2, DVB-S, so digital video broadcasting, terrestrial 1 and 2, satellite 1 and 2, and so on. What I'm going to do is the really simple operation. So I am going to just plug in the radio. Just looking for. Okay, nice. So it is detected. I. So I'm looking for the USB ID. So the USB ID of the radio is 1.8.5. So what I'm going to do is to update from the kernel. So I don't know if I can zoom. Yes. So I'm going to okay, activate and deactivate this block in order to simplify my demo. So what do we have here? So the first one, GNU Radio is like the Unix philosophy. Everything is file. So we have this first block, who is a file where we are going to read all kind of characters that coming in. So the file is called Pluto source because we have this kind of device. So we have some little field to fill. So the first one is the IIO context URI. So this is the USB address of the device. So I'm going to change it. So I told you it's a 1.8.5. Nice. Okay, so we are ready. This is the only things we have to set up. The frequency, the number of sample rates, so 2 million per second. The buffer rate, and the bandwidth. So we are sniffing 2 megahertz around this frequency, 434 megahertz. We are reading this file, and we are outputting in 2 blocks. The first block is Qt GUI, so we are just representing the bandwidth and the wave, the wave spectrum. We are just with this block just representing the spectrum, and with this block we are recording all the frame that arrived on the antenna of this device. So we can start. So first one, I just click on play, and it is not on the right screen. So this is what we are receiving at this time in real time on the device. So all the radio signal at 434 megahertz is received and represented here. What I'm going to do is to push the close or the open button. So I just push close, and you see that the key is transmitting a signal. The first one is on the right, on the left, and each time I push the button, you see that there is a rolling code that spread the signal between 0.5 megahertz or plus 0.5 megahertz. This is a security to be sure that if you listen to only one frequency, you only have 50% of the signal sent by the key. But the car is listening to the two frequencies. So the replay attack is the fact that the attacker will receive and record all this signal after being scrambled, and it will replay it in order to open. So this script is for open the door of my car. So I just have to record this signal and replay it when I come back to my home, and believe me, my car will open the door. So it is just the replay attack. For the relay attack, it is a little bit more tricky, but it's also a function. All I want to show you with this demo is the fact that when this system was built and prototyped, there aren't at this time this kind of device. The revolution is the fact that now the radio field is really simple to access. You just need 30 euros for this small USB key I show you, and 250 euros for this device. So for less than 250 euros, you can receive and transmit. With this one you can only receive. I want to show you a last demo. I hope the building will not obfuscate or not shading the data sent by plane, but okay, hope it's okay. No. What I'm trying to do is to dump this 90 mutability minus interactive. So just to show you the data, it's a little bit it's trying to put it at the window. You know what, I'm going to change the antenna to have more gain. What I'm trying to listen to is plane because all the stuff, all the things I told you with the cars is also in the airfield. I'm trying to receive the plane above of us, but I think the building, and I don't think it will change something. But I just let the laptop receive the data. I hope a plane will be above us at the zenith. I don't think you can open it. Or if you want, I can show you downside. Oh, the goal is to show you that a lot of signal of navigation system are not encrypted, authenticated, or signed. So every time we have this kind of problems, or the lack of security of authentication, signature, or encryption, we will have the opportunity to fake or to make fake packets, or to forge, or to have man-in-the-middle attack. What I show you on this kind of tire, or the software of the radio and the key fob of my car. So it is really important to understand that when we are designing device, when we are designing a new product, that every time we are transmit a data, every way or in every way we transmit a data, we must sign, authenticate, or encrypt the data, because it's a really open door to man in the middle kind of attack, or the opportunity for the attacker to forge some packet. So it was simple attack, but the fact that we don't take care of that in 2024, it gives opportunity to future attack. I think when I start to talk about the TPMS vulnerability, a lot of journalists and people was laughing. Believe me, since 2 weeks and the attack of the Israeli security service on the Hezbollah, and the fact that you can put in the supply chain explosive device in a device that receive on a specific frequency, a data on a specific frequency, a lot of people are calling me back and tell me the reality is now worse than fiction that we imagined 5 or 10 years ago. Believe me, in a wheel, in a tire, you can put more explosive, more explosive than in a pager or talkie-walkie, and can imagine that in this kind of tire, what can be the disaster if this kind of tire are exporting in Europe or in the US and so on, and have this kind of vulnerability. I will stop there. Do you have more questions? Yes? With the TPM MS? Yes. Does the car have a system that tells if the pressure or temperature increases, it slows down? No, it is there is no direct impact on the drive. It's forbidden. So you don't have a computer relationship directly to the accelerator or the brake. But the danger is the fact that this car is the car of people of interest, and that the driver just interpret that there is a mistake with the tire and stop. So if you start this attack at the right place, you can force the driver to stop at this place, and it can be on a motorway or a parking place and so on. And at this place, you start the real physical attack with gun and so on. But then with autonomous driving, not in Europe, but let's say in America, picking up more. Yeah. There will be automatic. It's a good question. It's a really good question. I have a video about the autonomous security, and yes, it will be. You're right. It will be a real problem, but because this is already the case with people who are disturbing the autonomous cars in big city in the US. What I'm showing you on this video, it's the red pearl driven by a cell phone. So it's me on the red pearl, so I'm not touching the wheel or the brake or the accelerator. And what is driving the car is this device. So it is not an official driving system, because I setting up, so you see that I am at more than 100 kilometers per hour. So with this device connected to the spin of the car can be driven autonomously. So in fact, yes, it's already, so this video is 4 years old. The system is more improved now with OpenPilot and Coma 3, the new version of this device. It is just on Neon. It is an autonomous 3 car. So the first one, when you have gear, automatic gear. The level 2 is the fact that you still have your hands on the wheel. At the level 3, you can put off your hands off the wheel, and the level 4 the car is exciting and going to the parking autonomously. At the 5 level you touch you touch nothing, and at this level I think yes we will have some problems if the sensors just send there is a problem with the wheel, the car will stop autonomously, of course, yes. Cameras of the cell phone and the sensors around of the car, and the leader, there is a laser in the in this part of the car that shooting the cars is front of me, behind, in front of me, and it is an open source software, so you can download it on GitHub, setting it up on your Ubuntu or any flavor of GNU Linux you have, on a Raspberry Pi. It is just a cell phone with a GNU Linux kernel, and a hard real-time GNU Linux kernel, and Android Y type of interface. But the challenge is just to decoding all the data is going through the car. So this is why I talk about the electronic way to hack the car. This is an electronic hack. We are just receiving all the data of the sensors, and in this cell phone there is a proxy. If the data is okay, it's going through the cell phone. It is not okay, and I just want to turn the wheel 15 degrees on the right or on the left, we will block the data, and the cell phone will generate the data in order to set to the wheel to turn on the right, on the left. So this car is unable to drive in roundabout. It's really too difficult. This is why I put my hand on the wheel in the roundabout. It is unable to respect the right priority. It doesn't understand or interact at this level at this time, and she can't decide with door at the toll on the motorway. When you are on a toll, it can choose autonomously which gates it will choose, but all the other things she's able to do it alone. So 4 years, after 4 years, I drive more than 200,000 kilometers fully autonomously with this kind of cars. No accident, and and 80% of the time I'm in autonomous mode. 20% is when I'm driving in a dense city, in the roundabout, but on the other part of of France, of Europe, the car don't need me to drive. So this is an ethical way to hack the car using OpenPilot. Again, it's open source. There is more than 200 cars already supported by this software. We have driven more than 12 millions of kilometers around the world, mainly in the US and in Asia. We are not a lot of guys or girls who are driving with OpenPilot in Europe, even less in France, but it's working. Other question? So I will stop. If you have, if you need to show or to see or to touch what my toys, because I'm always driving and coming my conference with my toys, I'm available here. I don't know if there is another conference at this place. I don't know if online you have questions. I don't know if there is a chat or so on. But feel free to answer me or to ask me question on LinkedIn and so on, if you have.
Very good. Thank you very
Merci.
much, and then we can go to more questions. So, do we have more questions? So my
Oh,
personal
yes, yeah, yeah.
it's
We
working.
have plane here. So, oh, so this is um, frame from on airplane above of us that we received. Uh, so this is the kind of signal we receive. What I'm looking for. So this is like a MAC address of the plane. So this number is a unique ID of the plane. So if I put this ID in flight radar or any kind of website, so just for the fun, I'm just going on your favorite search engine, and you just type ICAO Airbus 399 8. And you have the description of the plane. You will have his position in real time. So it's on Air France plane. That is going to yes. So that coming from, yeah, this one. So in each frame we have this small ID that is unique and that is stamped on the plane, on the IT of the plane. So even the plane is sold to another
Oh, really?
company or so on, until the dismantled until the
doesn't
plane
matter.
died, it will
Just send it as
always
fast,
have
the
this
letter is not fit in the
number.
letterbox.
So if you
On the
put this
website you
number
should
in
put
database, you
birth
have
date,
in real time. So this plane is coming from
the name, the birth date,
Tunisia.
the bank card,
It's
the secret number
it's
of the
going
bank card, and the
to
validity
Charles.
date.
I see it on the.
Yeah, but I mean
He's
nothing
going
happened. I
from
already
to
booked
Charles de
it, but
Gaulle, but he's coming from
still
Tunis.
stupid. But this is how it works in France. So these things are not uncommon.
That's right. So
I knew
this
that
this
before I got
data,
access
I
to
just
because
received the data
the
with
guy
a
another guy
USB
called me already
TV
on Monday that
receiver,
he would
just
deliver
act
something
on
by
the
letterbox.
right
And so
frequency,
therefore this was the only reason why I
1090
didn't
megahertz,
check it, because I was like,
and
yeah, I know it's
decoded with dump 1090 minus mutability, and you can do this kind of sniffing with a simple device that costs less than 30
and
euros.
I mean it's
And I stopped
luckily
here.
the most expensive
This is
bank I have,
the
so
real
it's
end of
completely
my
not
conference.
immediate and I was and so it's fine, and now I even post the card
So,
already
but
because
if you
it's
have
clear that
question,
it was
I'm
phishing. I mean the URL was fishy. And second, I checked on the not on the really reason was I immediately checked with my bank, because why should they take 99 cents and not 1 cent if they have to do the process? And there was nothing that happened. And then afterwards I checked the URL. I also didn't find anything. But then I thought, yeah, okay, I mean clever. They collected just all information even to call the bank. And then I just stopped it. I mean, the same happened with me like 3 years ago, 5 years ago with Apple. They had a fake Apple site. I logged in with my Apple ID, and then they showed also all my Apple devices. And then I immediately changed my Apple account, and also nothing happened. But I noticed it just was just 1 second too late, like this now. Je vais juste lui donner le certificat. Est-ce que toi t'es là demain ou pas?
Après-midi.
Est-ce que tu participes dans la cérémonie de clôture? Ok. Est-ce que tu as reçu un t-shirt? Oui. Ok.
Il y en a des gens qui sont passés qui en voulaient.
ça, c'est bon. Parce que je peux te donner ton certificat demain ou maintenant, quand tu veux. Parce que si tu es dans la procédure de clôture, je vais te le donner là. Parce que c'est plus festif, naturellement. Mais si tu n'es pas là, ou si tu n'es pas là, je te le laisse ici. Voilà. Parce que j'ai même imprimé